I had had enough.
Well, you drove out there into the middle of nowhere and had some sort of loud verbal display challenging ET in general out in the middle of nowhere?
That's what I was doing. I actually had a pistol in my hand at the time. I was really ticked off. When I was having this fit, I was waving the gun in the air, okay, and I had this fit. And at this moment, I said, okay.
He was a Louisiana man named Montaldos. Folks around called him Six Gun Joe. Worked with ICAR, don't you know? Investigating UFOs. Out for a drive with a gal one night, they stopped to check out the reporting site. When an alien lit right there on the ground, he commenced to throwing his weight around. Now, old Six Gun didn't take too kindly to that kind of thing, especially without Vaseline or anything like that, you know. Seriously. Well, Six Gun looked that critter right in the eye and said, "Any last wish before you die?" Yo, reached for his gun, quick as a twitch, and said, "Fill your claw, you son of a bitch." Now a legend spread across the land about this pistol-waving man. But if you're from space or from Earth below, you don't give no lip to Six Gun Joe.
Tune in to UFO Undercover, Wednesdays at 8 p.m. Eastern, with your host, Joe Montaldo, right here on the Paranormal Radio Network. Welcome to UFO Undercover, with your host, Joe Montaldo.
Good morning, everyone. I hope y'all are having a great morning around the planet. I'd like to, I know it's afternoon and evening for a lot of our listeners out there in the UK and Australia and New Zealand and around the rest of the planet to the 92 countries we go out to these days. I want to say good morning, good afternoon, or good night. I'm sure some of y'all are on Friday now, not Thursday, which always messes with me. But today's guest is going to be Dr. Michio kaku. Actually, he's a brilliant physicist, to say the least. And I've been dying to speak to him for about 3 years. I'm going to get him to introduce himself because I'm sure he'll do a much better job of it than I do. So, Dr. Kaku, can I get you to tell the audience a little bit about yourself, and we'll start from there?
Well, I'm a professor of theoretical physics, and my new book is called Physics of the Impossible, talking about things that are normally considered impossible, like invisibility, teleportation, ray guns, force fields, starships, antimatter engines, even time machines, but may be possible at some point in the future, decades, centuries, maybe even millennia from now. What I do for a living, by the way, is work on trying to complete Einstein's unified field theory. My goal in life is to complete Einstein's dream of attaining an equation perhaps no more than 1 inch long that would allow us to, quote, read the mind of God. An equation that will summarize all the physical laws of the universe into one coherent theory. That's my goal in life.
Well, I got to say it's a lofty goal. Unified theory, it fascinates me, and I really don't understand how y'all are going to actually achieve this. I mean, we're basically talking about everything in the universe being combined into one theory. I mean, you think it's possible in this lifetime?
Oh, in fact, I think we already have the theory. This is what I do for a living. It's called superstring theory. Mm-hmm. It's a bizarre, fantastic theory that used to generate snickers in the physics community, but not anymore. Now, all the smartest physicists in the world are dying to work on superstring theory. And I'm the co-founder of string field theory, one of the main branches of string theory. Time Magazine, Music Magazine, all the major networks have done stories on string theory. And just in a few more months, the largest machine of science ever created in the history of the human race is going to be turned on outside Geneva, Switzerland. It's called the Large Hadron Collider, and we hope to actually probe the periphery of this theory. So we may even have experimental vindication of it. The theory is bizarre because it predicts that our universe exists in 11-dimensional hyperspace, and there could be parallel universes. But we'll get into that. We'll get into that in another minute.
Yeah. Well, and that's the thing. I had remembered reading actually about you. God, it must have been 4 or 5 years ago, and I had just caught the glimpse 11 dimensions, and I'm thinking, wait a minute now, something's changing here. Mm-hmm. I mean, because really and truly, it's hard enough for most average people to understand that the dimensions that we actually physically live in, much less adding to them. I noticed that when you start talking to them about it, they kind of give you this dumbfounded look like, what are you talking about? Mm-hmm. And I don't exactly know why it is, but parallel universes is another thing that's also fascinating. I mean, now, when we talk about parallels, Dr. Kaku, are we talking about the opposite of this universe, or just another universe alongside or underneath this one that's basically moving along the same lines but slightly out of phase or slightly different than this one?
Somewhat. We think our universe is a soap bubble of some sort. We live on the skin of this soap bubble, and it's expanding, as all the astronomical data shows. And this theory, that our universe is a gigantic soap bubble, fits all the astronomical data. But now we believe that there could be other soap bubbles out there. Other bubbles floating in hyperspace, 11-dimensional hyperspace. And in my book, Physics of the Impossible, I even give you a diagram of the machine that just may, one day allow us to travel between universes. So in my book, Physics of the Impossible, I talk about 3 types of impossibilities: Class 1, Class 2, Class 3. Class 1 impossibilities are actually possible within maybe a decade, maybe 100 years. Invisibility, teleportation, ray guns, force fields, maybe even antimatter engines within 100 years, less than 100 years. Class 2 impossibilities include time travel. That may take centuries. That may take millennia before we have enough energy to bend time into a pretzel. But again, there's nothing in the laws of physics preventing such things. And so in my book, I realized that Class 3 impossibilities that really do violate all the laws of physics are very few. For example, perpetual motion machines. Mm-hmm. For what we can tell, perpetual motion machines do in fact violate all the laws of physics. But up to that point, a lot of technologies usually considered impossible, like telepathy, psychokinesis, are actually possible using the known laws of physics.
Well, see, that actually makes sense to me, because one of the things we study in the groups that I work with is psychic abilities. Now, I can honestly say I haven't found anybody that is that can move automobiles around or things like that, but I have found quite a few that seem to be very accurate at picking up thoughts and portraying them to others. Extremely accurate. Just kind of amazing.
In the book, I actually go through all the latest scientific studies. For example, look at telepathy. Mm-hmm. We have MRI scans now that are so accurate that you can actually pick up the patterns of a person telling a lie. With about 98% accuracy, you can tell whether someone's telling a lie on the basis of their brain pattern. Now, that's today. You can imagine that in 10, 20 years, we'll have an encyclopedia. An encyclopedia whereby looking at certain patterns of the brain, that corresponds to certain thoughts. So if you're thinking about dinner, that lights up a certain set of sensations in the brain. If you're thinking about, going to college, that sets up another set of brain patterns. And so we'll be able to create a dictionary, a one-to-one correspondence between certain primitive thoughts and certain patterns of the brain. we can already hook up the brain directly to a computer. At Brown University, stroke victims, people that are paralyzed and cannot interact with the environment, we can actually put a chip into their brain connected to a laptop. And by simply thinking, they can move the cursor on a laptop screen. That's today. We've already done that. These people can play video games. Now, think about this. These people are totally paralyzed. They're stroke victims. They can email. They can answer email. They can type in a crude way. They can play video games. And this is today. We can have a direct hookup between the brain and a computer.
Yeah, I noticed, it was about a year ago, I was reading an article on the F-22, and the Marines were talking about ordering 22s without joysticks in them. They showed it. It's basically a cap that connects to your head and picks up the response. I don't exactly know what it's reading. I mean, I read the article quite a bit. I still didn't understand it. The way they were explaining it is basically the thought of the motion was being picked up and transferred to the computer of the plane, and it was flying the plane. Now, I would imagine this is still extremely experimental, but Dr. Kaku, when it comes to what we know today and what our government knows, there always seems to be a nice sized gap there.
Yeah, and you know, in the future, it may be possible to put on a helmet and fly airplanes, drive cars, write emails, do video games, and move objects just by the power of sheer thought. And again, this is well within the laws of physics. And so we have to realize that in the coming decades, we're going to see miracles take place that are well within the known laws of physics.
Well, if you go back just 1,000 years, I'm sure, most of the science and physics then would have been considered most of what we do today impossible.
Mm-hmm. Right.
And that's something else I try to get across to our listening audience. They hear stuff like when we're talking about space travel or other dimensions. Oh, well, that's impossible. I said, well, no, it's impossible from what we understand today. Now, tomorrow, 1,000 years from now, see, for me, everything is possible. It's just a matter of learning how to do it.
Yeah, let me give you an example. I was on Peter Jennings' special on ABC television concerning flying saucers. And, there was the usual snickering. These are my friends, right? And they say that, well, the distance between stars is so great that it's impossible for a UFO to visit the Earth. Well, I mean, think about that for a moment. Technology 100 years from now, with that technology, we cannot reach the stars. Stars are really far away. The nearest star is 4 light years away. However, civilizations that could be 1 million years ahead of us, 1 million years ahead of us in technology, are conceivable, and that would be just a twinkling of an eye compared to the age of the universe, which is 13.7 billion years of age. So what we physicists do is we rank civilizations into 3 types: type 1, type 2, type 3. A type 1 civilization harnesses the entire power of the planet. They control the weather. They control earthquakes and volcanoes. A type 2 civilization plays with stars, individual stars. They use stars to fuel their machines. A type 3 civilization exhausts the power of the star, and they are galactic. They roam the galactic space lanes. So if you're a Star Trek fan, for example, the Federation of Planets would be an emerging type 2 civilization. They can play with individual stars, ignite them, and they've colonized the Alpha Sector, a tiny sector of the Milky Way galaxy. That's a type 2 civilization. The Borg, the Empire of The Empire Strikes Back, that would be a type 3 civilization, galactic in scope. Now, if you are a type 3 civilization, then traveling between stars is not such a big deal. They may already have mastered what is called wormhole technology. They may already have robot probes that can, that can colonize large chunks of the Milky Way galaxy. And we always assume that flying saucers come from a type 1 civilization. That's ridiculous. In the universe, we could have genuine type 3 galactic civilizations existing, and we wouldn't even know it. We are so primitive, we wouldn't even know that there's a galactic type 3 civilization in our backyard.
I agree with that. From what I can see these days, but that's the problem, I think, too, is, most humans can only perceive things from their own point of view and from whatever educational background they may have. And you're right, we're very primitive. I mean, we haven't even barely broke out of the womb yet. We've managed to make it to the moon. And to me, I got to be honest, after 50 years or 40-something years of space program, I'm not real impressed with how far we've gotten yet. But let me ask you this now, while we're talking about this. Isn't it possible, say, like, what is the universe, the galaxy, 100 light years across?
It's 100,000 light years across.
Yeah, so 100,000. If so, let's say that we built a base on the moon, and then we built a base on Mars, and maybe out in Zone L11 or something like that, and then maybe another base out on Io, and then one out at the Oort cloud, and then one halfway between here and Proxima and Centauri. Now, over 100,000 or 200,000 years, even at half light speed or a quarter light speed, we'd end up exploring the whole damn galaxy. So for me, any race that lives, 500,000, 1,000,000, 2,000,000, 5,000,000, 10,000,000 years should have easily been able to explore the galaxy even without light speed.
Yeah,
technology.
the way to do it is not to send Captain Kirk in a gigantic starship. That's really inefficient.
Mm-hmm.
The most efficient way is to send out tiny little nanobots, robots that land on the moon. Moons, of course, are very stable. There's no erosion. There's no rust. And these robots build a factory out of the soil by which they create copies of themselves. Not just one, but millions of copies of themselves. Then they blast off to go to the next set of moons, and they set up a factory, each one creating 1,000,000 more probes. So starting with one probe, you have 1,000,000. Then you have 1,000,000 times 1,000,000. Then 1,000,000 times 1,000,000 times 1,000,000. And pretty soon you have trillions of probes expanding near the speed of light in a sphere, colonizing all the moons of the Milky Way galaxy. And when they land on a moon, they simply set up a listening post, waiting for signs of an emerging Type 1 civilization. Now, this is the plot behind the movie 2001. Remember that movie 2001? There was that thing on the moon?
Yeah.
Well, that thing on the moon is a von Neumann probe. It's a probe that essentially is waiting for a Type 0 civilization like us to become a planetary Type 1 civilization when we become interesting to them. They're not really interested in us until we become Type 1. Then they would send a message back to the home planet. That's the basis of the movie 2001. Now, at the beginning of the movie, Kubrick actually had scientists, about 5 minutes worth of scientists, explaining all of this. But then, in a quirk, Stanley Kubrick cut the first 5 minutes of his own film, and the film became sort of semi-mystical. Mm-hmm. But it's actually the most realistic. It's actually the most realistic encounter with the extraterrestrial life in outer space.
Well, it was definitely interesting. I know it confused a lot of people, but I enjoyed it. And then I noticed he came out with 2010 to kind of ease the... Well, people were really confused after 2001. I'm like, God, it wasn't that complicated. Now, come on. I mean, it was an interesting movie. And
it's very realistic. In fact, you cannot rule out the fact that on our own moon is a von Neumann probe left over from a previous visitation by a passing Type 3 civilization. We are so primitive that we can't even detect such a probe on the moon. That's how primitive our technology is.
And well, we're definitely babies. That's the whole problem. And I think, unfortunately, our egos don't allow us to understand that in the grand scheme of the universe, we're very, very, very young. The planet itself is, around 5 billion, 4.5 billion years old.
Yeah, that's
and
right.
We've had life on it for, 1 billion years?
About 3.5 billion years.
Okay, and then sentient life, I guess.
Well, modern humans are only 100,000 years old.
Yeah. So I'm thinking, it's hard to argue. 100,000 years, that's not even a grain of sand on the beach. We're so far. Now, if we can live another 100,000 years, I would really think this species could contribute a lot and really develop a lot. But
within 100 years, we will be a Type 1 civilization, capable of harnessing a lot of the technologies that are so-called impossible. The internet is the beginning of a Type 1 telephone system. English will be the language of this emerging Type 1 civilization. The culture will be rock and roll, blue jeans, and youth culture. The economy will be like European Union, NAFTA. So you can actually see the birth pangs of an emerging Type 1 civilization. Every time I open the newspaper, I see graphic evidence of the birth pangs of a Type 1 civilization being born. And even terrorism can be explained. Terrorists are people who don't like this transition to a Type 1 civilization. They cannot articulate it. They don't understand what the hell is happening. They just instinctively know that we are merging. We are going toward a tolerant, scientifically literate, progressive society, and they fear that. They feel more comfortable being in a Type -1 civilization.
Yeah, old civilization. But it's one of those things, I guess. Part of this planet is going to be slow to evolve and slow to catch up, and unfortunately, religion will play a big part in that. And at this particular stage of evolution, it's going to be hard to get away from religion. I tell people all the time, you can be spiritual without having religion, but they don't listen to me. So, and organized religion is a downside. I mean, I got to give at least the Vatican credit that now they have admitted to sciences and the fact that there probably is life other than us. So at least that's a sort of a step in the right direction.
Right. Yeah. In 1600s, the church burned Giordano Bruno alive in the streets of Rome for saying that there are aliens in outer space. Because then at that point you have to worry, is there a pope out there? How many popes in outer space are there? How many Jesus Christ are there? A billion, a trillion? At that point it was simply better to burn Giordano Bruno alive in the streets of Rome.
Well, that's something else, and you can comment on this. I mean, one of the other things we discuss is if we have, like, say, 3,000-4,000 years from now, if we become a spacefaring race and we're going through the cosmos and we run across a planet like this one was, say, 2,000 or 3,000 years ago, and we do choose to land and mess with the culture, the only way they're going to be able to perceive us is as gods. They're just not going to be able to understand the technology, or that, we're not gods. So just everything will look like a miracle to them, when in fact it's simply science and technology. And I think that's actually the downfall to religion, is science and technology, because it's slowly but surely explaining away a lot of the mysteries and a lot of the miracles.
Take a look at Arthur C. Clarke's famous sentence that any sufficiently advanced technology is indistinguishable from magic. For example, magic is disappearing and reappearing someplace else. That's called teleportation.
Yep.
We physicists can now teleport individual photons and individual cesium atoms. We can take a particle of light, an atom, and send it across the Danube River. In fact, I was in the University of Vienna last year filming with BBC television, and we filmed the apparatus that allows you to teleport particles of light underneath the Danube River. You can bet that within 10 years, we'll teleport the first molecule. Within a few decades, we may teleport the first DNA fragment. I mean, think about that. Particles of life being teleported using our apparatus. And, Star Trek takes place in the 23rd century. That still gives us 200 more years to send Captain Kirk through one of these machines.
Well, I did remember reading about the experiment in Australia, which was only like 1.5 meters, and then I remember reading one about in the UK, which I think they said it was a whole kilometer or something that they had transported.
Well, now we can shoot it right underneath the Danube River. That's how fast it's moving.
And that's what I'm saying. I mean, this is a technology. Well, it's like when you were talking about nanites earlier. These are technologies that I would assume, in some shape, form, or fashion, we will see in the next 50 years. Now, I'm not saying they're going to be beaming people around a planet in 50 years, but things that are not alive within 50 years, we may actually be able to transport things like that. I'm sure it's a lot harder.
There's a movie, Jumpers, right? And in fact, I actually talked to the director of that movie, and he told me that if you could really jump, as they say in that movie, you'd have the power of a god. You'd be able to assassinate any leader by jumping right into his office. You could rob any bank. You'd have the power of a god if you could teleport like that. But anyway, we don't have that power today. However, it's conceivable that by the end of the century, we'll be able to teleport cells, organic materials. And who knows, maybe by the 23rd century, we'll be right on schedule for Star Trek.
Now, I'll tell you one thing, it'd be nice to have transporters, man. A trip to Europe would take, a few seconds? Not even that.
It would be
a millisecond or so?
Instantaneous, yeah.
Oh, yeah. I mean, it would be fantastic. Well, we talk about that a lot on the internet, being able to, like, if you were sitting here talking to someone, instead of, if you wanted to email them something you wanted, they lost their keys, or if they needed a piece of equipment, you could just type it into your computer and scan it and then send it across to them and it materialized right there, which would be a nice feature, I have to say. I love the internet. To me, it's one of the best educational tools ever invented. But unfortunately, there is a lot of BS on it. I'm not going to deny that fact, but I give people...
Oh, yeah, most of it is BS, in fact, on the internet. Yeah. But that's a good thing, because most humans engage in BS. So and it reflects humanity.
I tell people all the time, don't take it to heart. Do your research, do your homework, check out what people are saying. Most things are checkable and authenticatable, so take the time and do it, because I get a lot of emails and a lot of phone calls about some of the craziest stuff. I'm like, no, guys, look, go do your homework.
Yeah.
Then call me back. Now, we were talking about nanites, and nanites fascinate me for a lot of reasons, because like what you were talking about on colonization, but also along the levels of medical, in the medical field. I mean, you're talking about being able to go in and actually physically, basically eat the cancer away anywhere it is in the body, and then remove the nanites or have them just dissolve inside the stream. But things like clogged arteries or broken vessels or things along this should be easily.
Yeah, well, nanotechnology is still in its infancy. However, we've already made enormous progress in being able to create materials that could revolutionize society. For example, carbon nanotubes are stronger than steel, and in principle, they're so strong you can even build a space elevator. A space elevator would be a long string of carbon nanotubes stretching into the heavens. It doesn't fall down because of centrifugal force of the spinning Earth. So it's like Jack and the Beanstalk. You literally would climb up a tube of nanotechnologies, a carbon nanotube, into heaven. And that could revolutionize the space program. In fact, NASA has even set up a study group. Money is flowing in this direction to explore the possibility of a wire that goes into heaven, just like Jack and the Beanstalk.
It is. These kind of technologies, it's like we're on the precipice of what's coming in the future. We're standing there looking over the edge, just watching all these technologies build up underneath us. And I've got to say, I'm 45, and the world's come a long ways in the last 45 years. When I was born, it was just, 3 TV channels and black and white television, a few AM and FM channels, no real worldwide, no globalization like we have today. And so it's a changing place. And I got to give the internet credit for another thing, that it is bringing the world closer together. It's bringing the everyday people closer together.
Yeah, well, that's the emergence of a type 1 civilization. That's what we are seeing. All this builds up toward a planetary civilization. And that's what we are seeing right before our eyes, the birth pangs of a planetary civilization.
And I just seen a question go by. What was this? Where were we to achieve space travel beyond our moon solar system? And wait, guys, if y'all gonna type questions like that, y'all gotta make them clearer than that. That didn't make sense to me. And you can put your hands up, ladies and gentlemen. I will open up the virtual auditorium if Dr. Keiki don't mind taking questions. Maybe in the second hour we'll take a few questions. But
fine.
I got guys. I gotta be honest with you. I have like 500 questions sitting in front of me personally. I want to ask you. So I'm kind of greedy with the guests the first time I get them on the show. Usually I bring people back and let the audience have them for an hour and a half. But now, when we're talking, everybody always talks about faster than light travel, but there's lots of other ways to consider travel, such as wormholes themselves. So I'm thinking, I know we're trying to develop faster than light, and I understand, I was listening to a gentleman a few weeks ago, I can't think of his name, and he was talking about creating some kind of field around a spacecraft traveling at the speed of light to cancel out the effects, so that the ship can achieve light speed without critical mass. And it sounds plausible, but I'm not a physicist. Okay, and then they were talking about they got to talking about wormhole technologies. Now, then they got to talking about space sails at 3/4 light speed and stuff. Now, the space sail, I don't know about. These things are supposed to be 2 and 3 miles across. They're gonna have to build out of some serious material. It's still gonna have to be light, but yet strong enough to be bombarded by micrometeorites. Because so I kind of have issue with that. But right now, since we're thinking about going to Mars. Present technologies, what do you think is the best technology to get us to Mars?
Well, personally, I don't think we should put out crash programs to send humans to Mars when robots are cheaper, faster, they don't complain, they don't have to come back, they're not unionized. So robots, I think, is the way to go. However, that said, if you take a look at the long-term picture, the Earth is in the middle of a shooting gallery. We're going to have big problems in the coming centuries to millennia to millions of years. Another ice age will hit the Earth in perhaps 10,000 years. On a scale of 10 million years, a huge meteorite bombardment could wipe out all life on Earth. So as Carl Sagan said, we should become a 2-planet species.
Yeah.
A 2-planet species, an insurance policy. Again, there's no rush. We shouldn't spend $200 billion to put 2 men on Mars just for the sake of it. But as a long-term insurance policy, we should seriously consider that. And I think ion engines are perhaps the best bet for a long-haul mission.
Yeah, I had read something a while back about the ion engines and getting us to Mars in under 3 months and things along those lines. And I found that interesting. Now that makes it plausible to go there if you can get there in 2 or 3 months. That's not that big of a trip.
Right. Now, if you talk about 100 years, then new kinds of technologies enter the picture. One is to create nanobots, small microchips, size of molecules. You could easily accelerate them to the speed of light, because we do that in the laboratory all the time with electric fields. And you send trillions of them to the nearby stars, of which only a handful actually make it and come back. So using nanotechnology, these starships may not be big objects at all. They may easily fit inside a pencil. And you may send trillions of them to stars, and they will land on a moon of a star, create a factory of themselves, and then reproduce themselves, and then shoot their way back. That's very similar to the way a virus propagates. A virus is a very efficient way of colonizing a human being and giving it a cold. One particle of virus can colonize 1 trillion cells within about a week or 2 weeks and give you a cold. If nature does it that way, then perhaps we should explore outer space that way. So that's yet another way of exploring outer space with nano rockets.
Well, that's a feasible way, and there's also some other benefits to that. I mean, if you train the nanites to build not just their cells, but to build structures, that you could actually have mini outposts set up as man decided to get it. In other words, when they found something that was interesting enough for us personally to go look at, you would already have maybe a little landing platform or a little outpost or something where they can check in, when they're bringing equipment. Because I know if most of the raw materials for building are going to be found on just about any planet we land on. So, and I'm sure the nanites can be taught to do that. And if they can replicate themselves, then of course they should be able to replicate enough of them to send forward to the next point that they're going to, and have enough left behind to build some types of structures. And then they can become a nerd afterwards. But to me, it is a good way of doing it, Dr. Cage, I got to say, because first off, it takes a lot of the danger out of it for us personally. And it allows us to get out into places that we wouldn't be able to go, even if we had the technology. We probably wouldn't go anyway, simply for safety reasons. And this way, you're getting a bird's eye view. And I like the idea of doing it on the moons because they are stable, plus they're excellent observatories for planets. You can set up on there and you can watch it, and if it's a Type 1 or a Type 2 civilization, Type 2 would probably notice you, but Type 1 might not. And but you could observe them pretty much undisturbed and decide whether or not this is a species you want to make contact with or not. It does seem like an easy way of doing it to me. Now, NASA, though, unfortunately never does anything easy.
Right.
I remember reading in 2000, Boeing and NASA were talking about magnetic drives and gravity drive systems, which both fascinate me. Personally, I don't understand why the magnetic drive is such a hard thing to get to operate. It seems like a pretty basic principle to me. Basically, you're just reversing the field and using it to push against an opposing field and push yourself in. Of course, the more pressure you put on the field, the faster you should travel, and you should be able to pull and push across the planet quite easily. But apparently, it's more complicated than that. Now, they do have these, what they call those TRs, those black triangles that have been being seen all over the United States for the last 12 or 14 years. Everybody swears there's some type of magnetic drive. I've talked to a couple people in government that said they're magnetic drive systems. And they've been well documented. But what's interesting, people always call it, they think they're alien craft. But the places we videotape these is out in California near the Boeing facility, New Mexico, Arizona, and Colorado, and near Eglin Air Force Base in Florida. These are all air testing facilities for the U.S. Air Force. These aren't, places that an alien would come and land unless they want to be shot at. So, these are some type of conventional technology. Now, whether or not they're magnetic or gravity drive, I can't honestly say because I'd have to actually get in one and find out. But they're very fast. They seem to be completely stealth.
Yeah, well, let me say a few things about magnetic drive. Magnetism has pluses and minuses when you talk about a propulsion system. The plus side, of course, is that it's silent, and you could basically float in the air. The problem is that magnetism occurs with dipoles. Whenever you have a North Pole, you have a South Pole.
Yep.
And if I put a compass needle in a magnetic field, it doesn't rise. Everybody knows compass needles spin. Okay. So if you were to have a flying saucer or some device using magnetism, and you would turn on the magnetic field, it would simply spin. It wouldn't do anything but spin, which is kind of useless.
Yeah.
Now, in order to harness the power of magnetism, you have to go in two directions. One is, of course, go supermagnets, which requires superconductivity. That's something we can do today. The other possibility, though, is to use monopoles. Now, let me explain. A dipole is found in every magnetic field. Every time you have a north pole, you have a south pole. End of story. The thing spins in a magnetic field. Therefore, magnetism has never, ever been harnessed to go in a straight line. You cannot use dipoles to go in a straight line. That violates the laws of physics. However, if you have a monopole, you could then surf in any direction you want. Now, we physicists believe that at the instant of the Big Bang, there were large quantities of monopoles created by the Big Bang. You can even calculate the density. However, because the universe is quite big, we don't see monopoles anymore. They're spaced by quite a distance. If any civilization is galactic, they can harvest large quantities of outer space for monopoles, which we think are out there. The leading theory of physics says that there should be copious quantities of monopoles in deep space. They'll be able to harness these things. And if they harvest them, they could build a monopole drive, in which case they could then coast on the magnetic field throughout the galaxy, on the Earth, and maneuver, zigzag, which of course is impossible with a North Pole and a South Pole that simply spins in a magnetic field. So already you're talking about a Type 2 or a Type 3 civilization that can harvest monopoles in deep space. That would be possible, but it's not for Type 1, and it's certainly not for us. We are
Well,
Type 0.
yeah. Well, I can understand that because I keep I keep hearing them talk about these different drives, and and then I heard them talking about gravity drives, and I'm thinking, guys, as far as I can see, we don't even understand gravity fully. Let's how we build and drive systems. I don't know. And then the ion drive I heard a lot about. So
Yeah, they exist already.
yeah,
And we're going to use ion engines. We've already sent an ion engine into space. They're not so dramatic. They don't make your heart flutter by seeing the exhaust flames come out one end. It's like the inside of a TV set. They shoot out ions. And so it's not as dramatic, but it's certainly the method of choice for long-haul missions that are not constrained by time. And they may be the future of the space program.
We're going to have to do something better than rockets. This first off, they need to figure a way to get payloads into space without using rockets. And then once we get into space, we need a better drive system to get us around the. Right now, I mean, the only thing we should be worrying about right now is our own solar system anyway. We don't really have the technology to get out. What Viking's the only thing that's broke the solar system, and we really don't.
Pioneer and the Voyager.
Oh, Pioneer and Voyager. I say Viking. I get them. Oh, Viking was Mars. Okay,
Right.
sorry, wrong probe. But we really don't have the technology to really get out there and do anything. So, I mean, you establish a base on the moon, you establish a colony on Mars, you start moving your way further in the solar system. Eventually, you're going to get out to the Oort cloud in 50, 100 years. And at least then we're established inside of a solar system. So we have several launching points for other stars. And by then we may have developed some technologies that might get us there in 4, 6, or 8 years or something. I still don't know about setting up 8-year-long missions, but I do hear a lot of scientists talking about, generational ships and things like that. I'm thinking that's an awful big drain on resources, a generational ship. I mean, and 8-year space travel just seems like a long time. That's what half speed to the nearest star would be. Half a light speed would take about 8.8 years or something, and that's a long haul for anybody. So I'm looking to see technologies that get us there a lot faster. Now, of course, if we do have a base in the Oort cloud, and then we build another one, say 2 light years further out, then launching points from there only puts you at half light speed. You're only 4 years from approximately, and so on and so forth. So I mean, we can do it that way. It just seems like that's the hard way to go. It just seems like there should be a shortcut somewhere here, Dr. K, because something that can get us from point A to point B relatively quickly. But I guess we still got a long ways before we're going to achieve that.
Yeah, well, in my book, I have a whole chapter on starships. And again, we're talking about technologies that are for late this century, maybe next century.
Yeah.
But we are talking about antimatter. We're talking about ramjet fusion engines. We're talking about laser sails and nanoships. Those are perhaps the 4 leading candidates right now for a device that could take us to the nearby stars. But again, we know we are a Type 0 civilization. By the end of the century, maybe we'll be Type 1, in which case it may be feasible to send probes to the nearby stars. But to go faster than light, that would require Type 3 technology.
Someone just asked me, it says, ask Dr. Kaku, in which direction would he head towards the destination? I guess they want to know which way you'd want to go, what, in our own solar system, beyond our own solar system. Where would be the first place that you'd want to go outside of our solar system? Gee, that's a tough one, huh? Yeah, there's a lot of places.
Well, how far out?
It doesn't say. They just asked what would be the first place you'd want to head to outside of the solar
Well,
system.
there are a lot of stars out there that would be very nice to visit. Some of them would look very much like our sun. Alpha Centauri is a red dwarf, and so probably not so interesting. It's actually a triple star system, so probably there's no planets around Alpha Centauri. But there are a lot of other stars that we're going to be analyzing with the Kepler satellite, which is going to be launched later this year. The Kepler satellite could create an existential shock for everyone, realizing that there could be hundreds of Earth-like twins in outer space in all the familiar constellations. The Kepler satellite is designed to detect about 600 Earth-like twins in space, and we could have an existential shock looking at the night sky, realizing that here, there, in the familiar constellations, there are Earth-like planets capable of sustaining liquid water, in which case they may even have life, microbial life, maybe even mammalian life like us. So that's for this year.
Yeah, I actually remember reading about that. What's the smallest planet we can find right now?
Well, the smallest planet we can find right now is Mercury. Pluto has been pretty much demoted. It's no longer.
Oh yeah, I know it's no longer a planet. Matter of fact, that was a question on Jeopardy the other day. What's the furthest out planet? What's Pluto?
No, it's and beyond that is Xena, the warrior princess. They both been kicked out of the solar system of planets. Yeah, they're basically overgrown comets in the Kuiper belt.
Yeah, so we just put them down to a planetoid because they're not a moon or anything. Which Pluto kind of needed to put down. I mean, that thing is smaller than our moon. That never should have been considered a planet. But I was talking about right now outside of our solar system. What's the smallest planet we can see? What, about the size of Jupiter or larger?
Oh, you mean extrasolar planet?
Extrasolar
we can
planet.
see planets about the size of a Neptune.
Yeah,
a little bit smaller than Jupiter. A lot of them are super Jupiters in size, massive objects. But that's because their instruments are so crude that that's all they can pick up. And so we picked up almost 300 of these things in space. But again, they're huge objects because our instruments are too crude. But with Kepler this year, we have the possibility of finding Earth-like twins in space. And that could focus the SETI project. The SETI project, as you know, the search for extraterrestrial intelligence, got a shot in the arm a few months ago. And Paul Allen, the Microsoft billionaire, donated $26 million to create a battery of radio telescopes to really seriously look for signals from alien life in outer space. So the SETI people are quite elated. In fact, one of them even predicted that in 25 years we'll make contact. Contact in 25 years, he predicted.
Well, Paul Allen definitely believes in exploring space. He dumped a lot of money into it, and I'm glad to see somebody do it. Because, we've talked about this before. Privatization may be the way to get us into space. Things like, mining different planets, mining the asteroid belt, mining the Oort cloud. These are things for big companies that they might actually get into because sooner or later we're going to need these materials and there's going to be a demand for them. And if they can make a profit, they'll do it. So it's either going to be privatization or globalization, one of the two, because the United States can only do so much. We only have so much money and so much technology and so many people. So, I mean, it kind of limits us when we start talking about spending $1 trillion a year on a space program, and the Americans are going to flip. Of course, now we could take that $986 billion we spent on defense last year and put it towards the space program, and then we wouldn't even be losing any money. But of course, unfortunately, in this era, we still have to have defense, I guess. So that's something else. But I would think one of those two would get us into space a lot faster if we could figure out a way to privatize or to globalize the thing. I think we could get there a lot quicker. But whether or not that'll happen in our lifetime, that's anybody's guess there. Now, I know we touched on dimensions earlier, and kind of give me a breakdown for the listening audience what we're talking about here when we're talking about other dimensions and parallel universes and things like that.
Well, when I was a child growing up outside San Francisco, I used to visit the Japanese tea garden, and I used to spend hours looking at the ponds where fish swim right beneath your nose. And they live in two dimensions. They can only swim forward, backwards, left, right. They live beneath the lily pads, and their whole universe is a two-dimensional universe. So I imagine that if I was a scientist, a fish scientist down there, I would say, bah, humbug. There is no third dimension. There's only the pond. We can swim forward, backwards, left, right, but there is no up. Up is science fiction. There is no hyperspace. There is no third dimension. The pond is what we can see. The pond is what there is. Period. End of story. And then I visualize reaching down and grabbing the carp fish, lifting the fish into the world of up, the third dimension. The scientist would be shocked because he would see beings moving without fins, a new law of physics, breathing without water, a new law of biology, and then I put the fish back into the pond. What kind of story would he tell? Fantastic story of disappearing, seeing hyper beings in the world of up, and then coming back down into the pond. Now today, we physicists believe that we are the fish. We spend all our life going forward, backward, left, right, up, down, saying, bah, humbug, anytime someone talks about a world beyond the third dimension. But now we physicists think that perhaps there are 11 dimensions, and we now have some experiments that may prove it. For example, the Large Hadron Collider in Geneva, Switzerland, which is 17 miles in circumference, the biggest machine of science ever built, we hope will create what are called sparticles. Sparticles are higher vibrations of the superstring. The superstring only vibrates in 11 and 10 dimensions, so we may have glimmers of a proof that perhaps the universe was created in hyperspace.
Now that would be interesting in itself. Simply each now, let me ask you this. Now, when we're talking about dimensions beyond the third dimension, are we talking about in the fact of, say, there could be a whole, well, each dimension could house its own universe?
Yeah, think of parallel sheets of paper stacked on top of each other. Each sheet of paper represents an entire universe, but there's another parallel universe literally right on top of us that we cannot see. We are like flies stuck on fly paper. However, gravity does ooze between these universes, so we do think we can measure the presence of these other universes. For example, if there's a galaxy hovering just above us, we would feel the gravity, but it would be invisible because light goes underneath it. In fact, that's the basis of The Invisible Man of H.G. Wells. If you read the original novel, the Invisible Man became invisible not because of potions and chemicals, which is what they do in Hollywood, but because he was blown into the fourth dimension. He's hovering above us in the fourth dimension. So if there's a galaxy hovering above us, we would feel its effects, but it would be invisible. And some people think that that's dark matter. Dark matter is invisible. We can detect its gravity, but there doesn't seem to be anything there. That's why it's called dark matter. We know that 23% of the universe is made out of dark matter. So maybe dark matter is nothing but matter hovering above us in another dimension.
It's interesting in itself. Dark matter always has fascinated me, and now that they're finding out what the universe is actually, well, I shouldn't say they're finding out; they're still trying to figure it out. But as we go on, I like to call part of the universe the light universe, which is what I feel like Einstein's theories apply to, because there seems to be the darkness between the spaces, whatever they call it now. Not dark matter. There's another name for it. I can't even think right now. But it just seems like gravity is not going to work the same way there as it does here.
Well, we hope to prove these in the laboratory. I'm a physicist. We believe in measuring these things. For example, if gravity does ooze away from our universe into a parallel universe, then there should be slight deviations from Isaac Newton's inverse square law. Newton was famous, of course, for saying that gravity diminishes as a square of the distance. But if it is a higher dimension, then at short distances, gravity should diminish faster, like the inverse cube. the inverse quartic, the inverse quintic. And so we can measure these things. So at the University of Colorado in Denver, the first experiment ever was done to search for the presence of a parallel universe. Unfortunately, the results were negative, which to me simply means there's no parallel universe in Denver, Colorado. However, there could be parallel universes everywhere. We just don't know it because our instruments are too crude to measure the presence.
Yeah, I like the way you said that. It's not one in Denver, Colorado. Yeah, that's the thing. And I think as we become more technologically advanced, a lot of what we're talking about today will be much easier to prove. It is kind of a shame that we're limited. And don't get me wrong, ladies and gentlemen who are listening, we're not putting down the technology. For us, we're much more advanced than we were even 40 years ago, but we're talking about things on a much higher level here. And races that may be 1 million, 2, 3 million years old, they're going to possess technologies. Well, frankly, they're going to look like magic to us. There's not going to really be no other way to explain it at this point of our evolution. So it's kind of hard. But I got a question just came in from the virtual auditorium. So let me ask you this right quick. It says, quantum entangled particles affect each other intensely across large distances, but the no communication theorem states that we cannot use these to transmit information faster than light. Do you think there will ever be a way to get around this?
Well, let me say that, first of all, information can be transmitted faster than the speed of light. In fact, information is transmitted instantly, much to Einstein's chagrin. We've measured this in the laboratory. There's no dispute about this at all. The problem is that the information is random. So it's useless information that you transmitted faster than the speed of light. For example, let's say that you have a red sock and a green sock. You put a red sock on one day, and on the other foot, you put a green sock. And you alternate. Well, if you see such a person and you lift one pant and you see that the sock is green, then instantly, faster than the speed of light, you now know that the other sock is red, okay? But that's useless information. You cannot send Morse code this way. You cannot send a signal faster than the speed of light this way. The quantum entanglement, which is the basis of quantum teleportation, is a very nice way to supposedly show a deficiency in Einstein's theory, but actually Einstein has a last laugh. The information you send faster than the speed of light is random information. Therefore, it's rather useless. Now, there is a way, we think, of going faster than the speed of light, and that's to use general relativity, the theory of gravity that Einstein proposed, and that's with wormholes. A wormhole is a shortcut through space and time. Take a sheet of paper and put 2 dots on it. Most people think that a straight line is the shortest distance between 2 points, right? However, fold the sheet of paper until the 2 dots touch each other, then punch a hole, and that's a wormhole. A wormhole is the shortest distance between 2 points. The problem with wormhole drive is that it requires an enormous amount of matter and energy to open the hole and keep it stable. That's the problem.
You're talking about harnessing the power of our sun, basically.
Harnessing the power of a star. You would have to be type 2, preferably a type 3 civilization, in order to bend time into a pretzel, in order to create wormhole machines or time machines.
Now, didn't Einstein allow for naturally occurring wormholes?
Well,
Random,
Einstein introduced wormholes in 1935 with his student Nathan Rosen. He introduced a bridge connecting universes. It's called the Einstein-Rosen bridge. And so it was Einstein himself who introduced this concept. However, he didn't think you could actually go through it because back in those days, gravity was infinite at the center of the gateway. So as soon as you enter the porthole, you die in the process. So Einstein wasn't worried. However, now we find spinning black holes, in which case the gravity is not infinite at the center. Most black holes we see in outer space are rings. They rotate very rapidly. We think that they collapse into a ring, rotating ring. Centrifugal force prevents the ring from collapsing. And if you fall through the ring, you fall into a parallel universe.
Because I actually heard a lot of theories about wormholes being gateways to other universes or gateways to other universes, and they become stars in the other universe. When all the matter collapses here, it's reconstituted on the other side as a star. I'm like, well, guys, that's some pretty lofty theories. Until we go through one of them, we're not going to know.
Yeah, we're not going to know until we actually go through one of them.
Yeah.
And you know, the nearest black hole is many, many light years away. There's a wandering black hole in the Milky Way galaxy, by the way. We've been tracking it. It could sneak up on you and literally eat you alive, and you wouldn't even know it. We do now think there could be thousands of wandering black holes in the Milky Way galaxy. And they're pretty dangerous.
Yeah.
They could eat up the whole solar system, and it wouldn't even burp as it passed by.
They just suck us down and be nothing left. Well, don't they believe that there's a black hole at the center of our galaxy now?
Yeah, it weighs about 2 million times the mass of our sun. It's in the direction of Sagittarius. So tonight, look in the direction of Sagittarius, and by rights, there should be a fireball in the constellation Sagittarius. There's not because of dust clouds. Dust clouds obscure the galactic center. But the constellation Sagittarius should be brighter than the moon by rights. And it should light up the night sky like a Christmas tree, but it's obscured by dust clouds. And at the center of Sagittarius is a monster black hole.
That's what keeps our galaxy in check, I guess, for...
Yeah, kids ask the question, if the moon goes around the Earth and the Earth goes around the sun, what does the sun go around? And we now know the answer. The sun goes around a black hole.
Well, we know that's something we try to get across to people, too, that, Earthlings are basically already astronauts. We're living in a contained field, in a bubble, spinning around our own sun, which is spinning around the galaxy, and we circle the galaxy every, 200,000 or 244,000 now.
I forgot the rotation.
Yeah, I'd have to go look it up, to be honest with you, but I know it's a long time to get, but still we're traveling completely around our own galaxy, and I don't think most humans even understand that. They're kind of lost, and they're just kind of like, what? What do you mean we're astronauts? Well, guys, we're astronauts. Our planet orbits our sun, and our sun orbits the black hole in the center of our galaxy.
Yeah.
We're space travelers.
Right, and right now you're traveling at 1,000 miles per hour.
Mm-hmm.
That's the rate at which the Earth spins. So right now you are moving at 1,000 miles per hour.
Yeah, thank God, it's the only thing that keeps us on the planet.
Mm-hmm. Right.
We'd all go floating away if somebody asked me that one time, what happens if the Earth slows down? I said, we're in trouble if the Earth ever slows down.
Mm-hmm. Right, yeah, we're in deep trouble.
Oh, yeah. I said, just think about 3/4 of the ocean floating up into the skies. I said, oh, that'd be a joy, wonderful thing to happen. Mm-hmm. It is interesting how this works. But I know we're going to go to break right quick, ladies and gentlemen. When we get back, if y'all want to ask some more questions, we'll open up the lines again, and y'all can come in and ask, or you can type them in the first auditorium, whatever's easier for you. We'll be back in about 8 minutes with Dr. Kaku to talk about some more of this and quite a few more things that we haven't even touched on yet this afternoon. So everyone, please stay tuned to UFO Undercover. I'm your host, Joe Montaldo. I'm sitting and speaking with Michio, and we'll be back in about 8 minutes, so please stay tuned. Okay, and... Good afternoon, everyone, and welcome back to UFO Undercover. Like Natasha said, I am your host, Joe Montaldo. I hope y'all are enjoying the show so far this morning. I have Dr. Michio with us today. Kaku with us. I'm going to get his name right one of these days. I've only heard it 500 million times in my lifetime. I was thinking about it. You've pretty much been on every major news show there is. I know you've been on BBC. I thought you had been on CNN. I know you've done a lot with the History Channel and stuff. You're quite easily attainable. I know most of your theories now are either, what do you have, 5 books now?
Altogether, I have about 12 books.
Oh, okay.
A lot of them are for PhD physicists, so they're not for the general public.
Well, I know most of the ones, I think I've read 2, and when this one comes out, I'm going to get this one. I noticed that a lot of your writing is, though, kind of for the layman, or at least I understood it. So, the first time I had read Stephen Hawking's Universe in a Nutshell, I found it fairly easy to read. And then I had a lot of friends tell me it was complicated. I didn't find it that complicated. I thought it was kind of written for the layman. But I noticed, I think it was the last 2 you had seemed to be written to where the general public could understand the book, which is a nice thing because most especially Americans, don't know the physics from a hole in the ground.
Mm-hmm. Right.
That's when they start telling me all these things that are possible. I said, no, guys, look, physics rules out a lot of what you're saying. And I said, now, not to say that physics may not turn out to be wrong 100 years from now. I said, but in today's society, some of these things are not possible due to the physics of them. And, of course, that's not the answers they want to hear. They want to hear everything's possible. And I don't rule out anything that can be possible in the future. I rule out things that are considered to be impossible at today's technological level.
Mm-hmm.
Now, whether or not the government's 50 years, 100 years, or 10 years ahead of us, that's anybody's argument. I know they're more advanced because when I used to work for the U.S. Navy, I was an avionics specialist technician. I was advanced avionics and electronics is what I used to do for the Navy. I used to do all their hard electronics aboard the ships and on the airplanes. And I pretty much worked on every plane and ship we've had. And the thing about it is the chips we were using when I was in the Navy in 1980 are still more advanced than the 4.0 quad I have in my computer right now. And now that's a 30-year difference, because that was 30 years ago I was in the Navy, and those chips were better than the one I'm using today. Matter of fact, the motherboards we were using were only partially silicon-based. I can't even probably get into it no more now because I'll probably break a security agreement, but they were only partially silicon-based. They weren't complete silicon chipboards like we use today. They're a different type of board, and they were much more efficient, and they didn't get near as hot as the boards we're using today, and the chips didn't either. So that's a technology they still have that still hasn't been made readily available to the general public yet, and probably won't be for another 20 years. I did see something interesting. I don't know if you had read up on this. The Japanese have been working on a carbon-based chip that they grew two chips, but nobody can figure out how to write to the chip. Nobody can figure out how to write software for the chip. But they're saying these things can run at 100,000 megahertz and have no residual heat whatsoever.
Well, ultimately by 2020, silicon power will be exhausted, and we could be facing a huge depression. We have to go to the next generation beyond silicon, in the post-silicon era. That's why we physicists are looking at quantum computers, molecular computers, protein computers, DNA computers, optical computers, plasmonic and photonic computers, because your laptop is going to be obsolete by 2020.
Oh, yeah, I can imagine that. Well, most technology, I mean, the first computer I ever bought compared to today's standards, would be considered a dinosaur at best. I think the first one I had was a 10 megahertz processor. You still had to use DOS. There was no such thing as Windows. For y'all who are spoiled using Windows, okay? For us people who were pre-Windows, we understand that using a computer in the old days was actually work. Oh, Lord, I still remember typing out code to paragraph line to get it to go somewhere or do something. But today, I got to give Bill Gates credit for that. When he invented Windows, he made computers idiot-proof, basically. Any person can use a computer now. Whereas before, you actually had to know what you were doing to use a computer. You had to understand the science of computing to use it. But in today's society, no, guys. You can go to the store, buy a computer, be online in 15 minutes, and doing all kind of stuff that you could never even think of before. But that's something else I want to talk to you. I mean, when we're talking about computing power and things along, I've heard a lot of things like biochips and things along those lines, where that you're basically going to grow a chip in a petri dish. There's not going to be really any expense involved. The chip, in some shape, form, or fashion, technically is alive, for a lack of a better. I don't know if I would call it alive, but in a sense, it is alive. It's a living chip.
I have a chapter in my book, Physics of the Impossible, about artificial intelligence and the future of computers. And first of all, you talk about bionic chips. First of all, you have to realize that the human brain is not really a computer. It's not really a digital computer. There's no Pentium chip in the brain. There's no software. There's no windows of the brain. There's no programming of the brain. There's no subroutines. None of that in the brain. The brain is a neural network. The brain is a learning machine. It's a bunch of neurons that simply readjust themselves after you learn something. You can remove half the brain and the brain still functions. In fact, there was a young girl who had half her brain missing, and she had headaches, and she complained, and the doctor found out she had half her brain. She was fine. In a computer, you remove one transistor, and the whole thing collapses. So artificial intelligence, that is the interplay between life and computers, when we have machines that act like living organisms, has been pretty much stalled for several decades now. The human brain is much more complicated than we thought. It has an architecture different from any digital computer. And basically, there are two reasons why we don't have robots, as I mentioned in my book, Physics of the Impossible. The first is pattern recognition. Robots can see. They don't understand what they see. It takes them about 6 hours to walk across the room because they cannot recognize chairs, tables, carpets, cups. They see these things. They don't recognize them. Second, they hear better than us, but they don't understand what they are hearing. They have no common sense. They don't know that water is wet. They don't know that mothers are older than their daughters. They don't know that strings can pull, strings cannot push. They don't know that sticks can push, sticks cannot pull. They don't know that when you die, you don't come back the next day, and that animals do not like pain. Now, we know all these things. We know that strings can pull, strings cannot push. That's just common sense, right? Well, robots don't have common sense. They've never interacted with strings. They've never pushed a stick. They've never seen a mother and a daughter combination. They don't know that animals do not like pain. You have to teach them this. And so how many lines of common sense are there?
Oh, Lord.
Several 100 million lines of common
at
sense
least.
are necessary to program the common sense of a 3-year-old child. That is the fundamental reason why we don't have robot maids, butlers, robot secretaries. That's the fundamental reason why we don't have robots.
Because you're talking terabytes of information.
Oh, much more than that. You're talking
probably
astronomical, more than a trillion bytes.
And that's the thing. And oh, Lord, trying to teach. And then you got to be able to put all this into code. You know,
there is no code.
Yeah.
The brain has no coding at all. Zero coding, because it's a neural network. Neural networks do not require coding. They simply learn.
Yeah, that's what I'm saying. I mean, we learn, so what we learn, we'd have to figure out a way to translate into code so we could teach the computer to do
code, not the brain.
Yeah, and that just seems like a daunting task in itself. Plus, not just that, I noticed that our technology really hasn't got advanced, you know, to make the opposable thumb work correctly and fingers work correctly and toes. And these are all things that we're working on because, you know, I did read that article a couple of weeks ago about, they called it the bionic arm. That's not actually what it is, but it's an artificial arm. It has 5 fingers. It looks pretty much like your arm, and it works on electronics. It'll probably be released, I think they said, in 2010. They're saying with this and the new legs, you won't be able to tell that a person has lost a body part. And they will be stronger than the average arm or the average leg would be.
We're getting very good at being able to mimic parts of the body. For example, Asimo, the robot made by Honda, it is the world's most advanced robot. I've actually shaken hands with Asimo for a BBC Science special, and I'll actually be visiting Asimo next week. I'm going to Japan next week, and I'll be shaking hands with Asimo a second time. But Asimo has the intelligence of a cockroach, a retarded cockroach, a lobotomized, stupid, retarded cockroach. It is basically a tape recorder. You cannot talk to it. You cannot converse with it. It simply says what is pre-programmed. It walks, it can dance, it can run, only if it's pre-programmed to dance, walk, and run. And that is our most advanced robot. We constantly overestimate how advanced our robots are. Artificial intelligence turned out to be much more difficult than anyone ever expected.
So, well, I just seen a question go by, and it's actually a 2-part question. They wanted to know, when do you think artificial intelligence will actually be artificial intelligence, and when do you think it would surpass, say, human intelligence?
Okay, first of all, the next big thing will be machine intelligence.
Yep.
That is pre-programmed rules of logic that can be answered by yes or no, like robo-doctor. When you go to the doctor, 99% of what you tell the doctor can be answered by yes or no, okay? We'll have those systems. In fact, already on the internet, you can type in many symptoms, and the internet gives you a primitive diagnosis. Robo-lawyer is next. So you'll be able to type any legal question, and the computer will give you a yes or no answer about lawsuits, about torts, and things like that. But common sense, that is the ability to gossip, the ability to schmooze, talk, chit-chat, small talk, that's way beyond the capabilities of any computer. A computer cannot recognize a fairy tale. Take any fairy tale, read it to a robot, and a robot guaranteed will not be able to understand the fairy tale that you just dictated to a robot. That said, in the next few decades, we do expect to make progress. Right now, our robots are as smart as a cockroach. However, I can see that in the coming decades, they'll be smart as a mouse. Mouse intelligence, okay, will be perhaps the next big leap for artificial intelligence. After that, we'll be able to have robots as smart as a rabbit, then a dog and a cat, then perhaps a monkey, okay? Now, when you have robots as smart as monkeys, then they become dangerous.
Yeah.
Monkeys have their own agenda. They have their own attitude toward things, and we're going to have to put a chip in their brains to shut them off once they have murderous thoughts, okay? So I do think that robots in the coming decades could become dangerous, not anytime soon, but we'll have plenty of decades before we have to put chips in their brains to shut them off when they start to get dangerous. I would suspect that by mid-century to late 21st century, we'll probably have robots as smart as dogs and cats. But that's mid-century.
That's pretty good, though. I'd be impressed with it. I mean, you can teach a dog a lot of things. So, I mean, if you can teach a robot that, it could do a lot of stuff. And maybe that's something we should think about in the future, though, is maybe limiting our robots to how much intelligence we actually give them.
And by the way, for those people who talk about visitations from aliens from outer space, it's conceivable that once we do make contact with an intelligent species in outer space, if they can visit us, they're perhaps 100,000 years more advanced than us, in which case they will probably have already redesigned themselves and already are part cyborg, part genetically modified. We're beginning to do this right now. We can see that in 50 years we may have designer children. That is the ability to actually monkey with the genes of our progeny to determine the genetic heritage of the human race. So if we meet aliens that are 100,000, 1 million years more advanced than us, chances are they have probably already redesigned themselves. We can foresee that within 100 years.
Yeah.
Well, talk about a civilization 100,000 years more advanced than us. They may have already redesigned themselves.
Well, no, I agree, and that's one of the things I have heard that talked about a lot on our planet. And there's a lot of moral issues dealing with this. That's why cloning, has been banned in so many countries. Personally, I don't know. I'm still in the middle of the road on this because I can see where a lot of these things will benefit us in a lot of ways: better hearing, better eyesight, stronger arms, stronger legs.
Cure disease.
Yeah, cure disease. There's a lot of things I can see where it's going to benefit us. The things that worry me and probably a lot of other people are we're going to start building super soldiers, to police the planet with. That's a threat in itself because they may decide they want to take over everything for themselves. You get into a lot of things here because of the poor use of technology, or poor judgment, I should say, by
I think
leaders.
in the short term, the real danger is not super soldiers so much. It's designer children.
Yeah.
Because every parent is going to want their kids to be competitive with the next door neighbor's kids.
Yeah.
If there's a rumor that the Joneses kid has been designed to have better memory, which is possible, we think, we can have mice with better memory. We found the gene for that. Well, then perhaps parents will want their kids to have better memory too.
Yeah.
And then you have a bootstrap effect, and everyone's going to be clamoring for illegal genes. You can ban the genes, but there's always going to be some place in Hong Kong, some underground laboratory that'll offer designer genes for $10,000.
That's the truth too. They will, and it's going to be funny because these children will be faster, smarter, brighter than the previous generations. There'll be somewhere in our near future where there's going to be a gap between the children and the adults, a much wider
it's
gap.
happening very quickly. The Olympic Committee has already set up, the Olympics have already set up a committee to look into not just steroids, but genetic modification of athletes. The Schwarzenegger gene has been found already. It makes mice muscle-bound. They call it the Mighty Mouse gene, but we found the human counterpart for it. So the human counterpart actually exists to make humans muscle-bound. And when the announcement was made at the University of Pennsylvania, a lot of phone calls came in, but it was quite depressing. 50% of the phone calls coming in came from muscle builders who wanted that gene.
Oh, yeah.
So that the Olympics are going to have a big problem in the near future.
Yeah, there's going to be a lot of those problems. But as we technologically advance, we need to also check our morals and keep ourselves in standard. And it's going to be hard, but a divided world. It'd be much easier if this was a united planet to control a lot of this stuff. But being that you have the United States and China and countries like Iraq, and it's going to be hard to control a lot of what goes on simply because we don't have any control over it.
Yeah, well, control is not necessarily what is required. We are headed, as I mentioned, toward a planetary civilization, a Type 1 civilization. And a Type 1 civilization is, in some sense, inevitable unless we blow ourselves up.
Yeah.
Globalization, the Internet, the European Union, all of these are signs that an emerging Type 1 civilization is going to take place. But not that it controls us like 1984. The Internet has already guaranteed that 1984 is not possible.
Yep.
Okay. So I think the greatness of the Internet is that it makes it impossible for one dictator to control all the information on the planet. It's already too late, I think, for 1984.
Well, because like people like myself, I have right now we have 11 computers online, totaling 14 terabytes of data. I've got copies of stuff that, well, all kind of stuff. You'd be amazed at it, from physics to ancient history to ufology to everything in between. And I know there's a lot of people out there like me. So yeah, you're right. I don't think you could actually control the information at this point. You'd have to have some kind of complete global change where that somebody could control, the actual internet itself, which I just don't see that happening anytime. And the globalization is something we're headed towards. I believe sooner or later the people will force the politicians into basically a one world. Because as we become more friends, one of the things I found out about 8 years ago when I got on the internet is when I was talking to people like in Russia or China, they were like, well, you're just like I am. I'm like, yeah, I go to work. I got kids. I got to take care of my family. I'm worried if I can eat or if I can do this, if I can do that. I said, we basically all are the same kind of people and have the same kind of problems. It's the politics of our country that create the problems. Mm-hmm. It's not so much the people. And what's happening here on the planet now is the people are starting to realize it. They're realizing, well, wait a minute, Americans aren't here to kill us all, and the Chinese aren't here to conquer the world. The Chinese person don't care what Americans are doing. They're more worried about their own life. Mm-hmm. It's the governments that are the problems, and until such a time, that the people force the issue, we're going to have these problems. But I do think eventually everyone will get tired. One thing I learned a long time ago, you can keep the people down, but you can't keep them down forever. Sooner or later, they're going to get tired, and they're going to rebel. So for as far as I can see, as long as, like you said, we don't blow ourselves up, we should move to a type 1 civilization within the next 50 to 100 years. Probably 100 years would be a better estimate, but
yeah, probably 100 years. At the rate at which we're consuming energy on the planet, about 100 years, we will have a planetary civilization.
Now, I know I don't know if you talk about this in the new book, Physics of the Impossible, but I hear a lot of people talking about 0-point energy, and frankly, I don't know enough about it, or I don't understand it. And I just wanted to get your take on it right quick.
Well, we do know that nothing, the vacuum, contains energy. In fact, you can measure it. It's called the Casimir effect. And so the vacuum, nothingness, is not nothing. It's actually teeming with subatomic particles that are darting in and out of the vacuum. These are called virtual particles. In fact, that's where the word virtual reality comes from. They stole it from physics. These virtual particles dart in and out of the vacuum. However, it's a very small effect. The Casimir effect can be measured. You have two parallel plates. Normally, these two parallel plates sit there and do nothing. They're just two empty parallel plates. But actually, they're attracted to each other, which means that you have a state of negative energy, which was once thought to be impossible. But it's very tiny. It's about the force of a tiny ant, the weight of an ant divided by 1,000. Oh, Lord. That's the pressure created by 0-point energy. Now, some people like to quote Nikola Tesla, who thought that perhaps energy could be extracted from the vacuum, okay? Mm-hmm. But how much energy is there? It's very tiny. And so, some people have claimed that maybe 0-point energy will take us to the stars. I don't think so. I mean, unless you can show me the equations and the apparatus which allows you to extract 0-point energy, it's very small. It would take a type 3 civilization to really extract 0-point energy in a big way. Now, that said, there is one practical application for negative energy of the Casimir effect, and that's to drive a time machine. It turns out that these Casimir machines, which we've measured in the laboratory for several decades now, have negative energy, which was once thought to be impossible. Negative energy is the energy necessary to stabilize a time machine. And so many physicists, Stephen Hawking, many physicists have written about negative energy as a way to stabilize the wormhole so it doesn't collapse on itself. But again, you calculate how much negative energy you need. You need negative energy comparable to the planet Jupiter. Planet Jupiter. And who can manipulate Jupiter? Even a positive energy Jupiter would be difficult to manipulate. A negative energy Jupiter would be more difficult. So you are talking about a type 3 civilization. You're not talking about some inventor claiming that they can harness 0-point energy. I don't think that's going to happen.
Yeah. Well, I don't either, but that's what I said. I didn't understand enough. That's why I asked you about it. See, it actually makes more sense to me now. Because I was talking with a few friends of mine, and they kept quoting on Dr. Greer, and I'm like, God, I'm telling you, I don't think y'all understand what 0-point is. And I realized you were coming on the show. I said, well, I'll ask. Mm-hmm. I said, because it's not making any sense to me. And I said, if it doesn't make any sense, it's not going to work. And it's just one of those things I was curious about, because I know it was a real thing, but Well,
it's real, but it's very tiny.
Yeah, it was like antimatter. They were talking the other day. I forgot. I was watching one of the science shows on Science Discovery, and they were talking about antimatter and how expensive it is just to make it, and we really can't contain it yet. And if we ever can figure out how to make it cheaply and contain it, then we might be able to use it to go to the
Yeah,
stars.
I have a whole chapter on antimatter in Physics of the Impossible. First of all, antimatter was not discovered by Gene Roddenberry. Gene Roddenberry stole it from physics. It was 1929 when physicist Paul Dirac predicted the existence of antimatter, and he won the Nobel Prize for it just a few years later when we actually discovered it in the laboratory. You can play with antimatter in small quantities. When I was in high school, my high school science fair experiment was to photograph tracks of antimatter and then to eventually create antimatter with an atom smasher. That was my science fair project in high school, for God's sake, okay? Now, at CERN in Geneva, Switzerland, and also outside Chicago at the Fermi Lab, we can produce beams of antimatter, but it's very small quantities, not enough to light up a light bulb, for example. We can create anti-atoms of hydrogen. We have antiprotons, and circling the antiprotons are anti-electrons. So anti-chemistry is certainly possible. We have already created anti-hydrogen atoms, but it would bankrupt the United States of America to make an antimatter bomb. There's even a novel by the guy who wrote the Da Vinci Code, where he talks about an antimatter bomb blowing up the Vatican. Well, you could do it, but it would just bankrupt the United States. Ordinary dynamite is much cheaper than that. But eventually, we do hope to use antimatter to perhaps go to the stars. Antimatter rocket ships are, in principle, possible, but it would take a technology maybe 100 years more advanced than ours to do it. But in my book, Physics of the Impossible, I even give you some of the numbers necessary to build an antimatter rocket ship.
It seems like the way to go. Of course, like you said, we're a long ways from really understanding this and building it. Because I had heard, one of the guys was talking about spaceships, but he was also talking about using it to power your cars and power your homes. And I'm thinking, guys, I don't know, maybe 1,000 years from now, but I don't see it happening anytime soon. Besides, what worries me about antimatter, I mean, like a grain's enough to probably wipe out half the United States if it was to blow.
If you had a few teaspoons of antimatter, that would be enough to blow up the entire metropolitan New York area.
Okay, I was wondering how the ratio worked out on that. But it seems like a good power source if we can figure out how to get it cheaply and contain it.
One possibility that the Russians have actually mentioned is to harvest antimatter in outer space. We have a satellite launched care of the Russians and some European countries looking for naturally occurring antimatter, perhaps an antimatter meteorite someplace in the galaxy. Everywhere we look, we don't see naturally occurring antimatter in any large quantity. There's a fountain of antimatter coming out from the center of the Milky Way galaxy. We think that's probably created by black holes. But other than that, we really see no evidence of large quantities of naturally occurring antimatter. And the reason is we think that the Big Bang probably destroyed most of the original antimatter. We think that at the beginning of the universe, there were equal quantities of matter and antimatter, except a slight more amount of matter than antimatter. When the two annihilated, because they will annihilate with each other and create an explosion, most of the antimatter disappeared into energy, gamma rays at that point. But a slight amount of matter was left over. We are the remnants. You and me and everything around us is the remnant of this ancient explosion between matter and antimatter.
Yeah, that's why they say we're all star stuff.
And more than that, we're cosmic dust.
Yeah.
We're made out of the dust that created the universe.
Yeah, that's the thing. I was talking with a group. I was doing a lecture not too long ago, and we were talking about everything in the universe is made up from the same material, and they're like, well, no. I'm like, well, yeah, it is, guys. It's just rearranged differently.
Yeah, except for dark matter. We used to think that
matter.
everything was made out of atoms, but now we have dark matter.
Yeah, which we're still trying to figure out.
Yeah, we think it's a higher vibration of the superstring. As I mentioned, in just a few more months, we're going to turn on the biggest machine of science ever conceived. It's the Large Hadron Collider outside Geneva, Switzerland. And we hope to pick up particles, higher vibrations of the superstring, and also maybe even dark matter, and maybe even mini black holes. That's been seriously looked at. These mini black holes are not dangerous. They're not going to eat up the Earth. They're very microscopic, subatomic in size. They wouldn't even light up a light bulb. But we do expect that we will create exotic matter in the Large Hadron Collider starting this summer.
I've seen a question go by about that. It says, how real is the danger of the Large Collider creating what is that, strangelet that could destroy the Earth?
Well, there is a bizarre theory that most physicists don't take seriously. If you have what is called strange matter made out of quarks, we're all made out of quarks. There are strange quarks. It's like the Midas touch. Midas was the king. Anything he touched turned to gold. Well, if I have strange matter and it touches non-strange matter, it converts it into strange matter, just like King Midas. So conceivably, it could be like gray goo. It could absorb the entire universe. Everything it touches turns into more gray goo, or strangelets in this case. However, I don't know of any physicist who takes this seriously. Okay. However, it was a theory that we proposed decades ago, and I think people proposed it maybe like when mothers talk about the boogeyman in order to make the kids go to sleep and eat dinner. It's sort of like a fairy tale that some physicists cooked up to scare the hell out of people. But no physicist takes it seriously.
No, that's good to know. As long as y'all don't go bleed, look, y'all do whatever you want, just don't blow the planet. I tell my physics friends and my science friends all the time, look, I don't care what you're doing, just leave the planet alone. Let's not create any super bugs or any super explosions or anything.
Right.
That's like our lovely president ordering that 250 megaton nuke. I'm like, what do we need that for? What do we need any nuke that's 250 megaton? And then they're talking about multi-warheads. I mean, come on, what do we need that for? Unless you're going to use it for energy, I don't know what we need it for.
Yeah. The biggest hydrogen bomb ever detonated was 100 megatons.
Yeah, and
so it's something that we don't need.
Yeah, I just don't see why we need anything along those. Now, what was I going to ask you? Oh, just totally slipped my mind.
One thing I want to talk about.
Go ahead.
We hope to create a mini Big Bang in Geneva, Switzerland, starting later this summer when the machine gets turned on. And one question we hope to answer is what happened before creation? We have a theory now, string theory, which is what I do for a living, that will actually take us before the Big Bang. And so the dynamics of pre-Big Bang physics is one of the hottest areas in physics right now.
Oh, I imagine.
Scores of papers being published by physicists. And we think that perhaps, well, there are many variations, but we think that perhaps before the Big Bang, bubbles, like our universe is a bubble, bubbles either popped out of nowhere, or bubbles collided with other bubbles, or sprouted baby bubbles. Like if you take a bubble bath, sometimes bubbles split in half, and then you get a baby bubble shooting out. Well, that bubble bath is the multiverse. Each bubble represents an entire universe, and we live on the skin of one of these bubbles. So Big Bangs happen all the time. So bubbles can peel off baby bubbles, and so perhaps this is how our universe got started. Now, believe it or not, we can test this theory. In the next decade, we're going to launch LISA into orbit. It's a gravity wave detector. We'll have baby pictures of the instant of creation, a baby picture of the infant universe emerging from the womb, and perhaps we'll find evidence of an umbilical cord connecting our infant universe to a parent universe. That's in the next decade. A new satellite, which will perhaps take us before the Big Bang.
Now, that'll be interesting in itself. I'll be waiting on pins and needles to hear about that one, because I've heard a lot of theories about pre-Big Bang. But I got to be honest with you, I still have issues with the Big Bang.
Fire away.
Well, I was reading a couple of months back. I was reading some articles, and they were talking about some of the galaxies seem to be clustering together, and some of them don't seem to be moving outward at all. And then they were talking about some of the outer galaxies seem to be younger than some of the inner galaxies, which should be the opposite way. If everything started from the center and was moving out, your oldest galaxy should always be out on the end.
Well, where did you read this?
This was
it wasn't Spider-Man comics.
No, it was a science journal that I get that's sent to me. I get it. I'd actually have to look at the name, but I get it. It comes in about once a month.
Let me tell you this: the Big Bang Theory has thousands of data points that fit the data, that fit the theory, and there's not a single exception. Now, some of my students, of course, come up to me and say, "Professor, what happens if I don't believe in the Big Bang Theory?" Well, I tell my students, it's a free country. You can believe in anything you want. However, if you have an opposing theory, your opposing theory has to explain thousands of data points, not just one, thousands of data points, Every single data point fits the Big Bang Theory. If one data point were to miss, we'd have to throw out the entire theory. That's physics, okay?
Yeah.
We're very cruel. If your theory doesn't fit all the data points, we throw it out. So far, the Big Bang Theory fits everything. There's not a single known deviation to the Big Bang Theory.
Okay, I'm waiting to see. I'm patient. If nothing else, I'm patient, and like I said, you know, I'm a layman at physics at best. I understand it probably better than most everyday people.
What you referred to though is clumping of the galaxies.
Mm-hmm.
If you take a look at the distribution of galaxies in outer space, they do clump. But the clumping again fits the Big Bang Theory because the Big Bang Theory accommodates dark matter, and dark matter will cause galaxies to clump.
Okay.
So it's another perfect fit.
Because you know, I was just thinking it was some kind of weird, a gravitational field or something, or maybe the center galaxy had a heavier gravity than the rest, and they were just kind of orbiting around it or something. But it is interesting to see it. And that's interesting too because those galaxies all seem to be a lot closer to each other than we are to say the Andromedan galaxy. I guess so. If you were traveling interstellar space, it'd be easier to get from point A to point. It'd be shorter.
Well, we are headed for a collision course with Andromeda.
Yeah.
It is our nearest galactic neighbor, and in about 10 billion years, we're going to be eaten alive by Andromeda. Andromeda is bigger than us.
Yeah.
And it's gonna rip apart the arms of the Milky Way galaxy, and the two galaxies will probably merge into a gigantic black hole about 10 billion years from now.
What you know, that brings up something else too. I had seen on Science Discovery. They were talking about, what was it? Something that had passed by this galaxy 2 billion years ago, and they said they think that they even thought that maybe Earth could have been one of the solar systems that were deposited by this passing by. It's like something had brushed along the edge of our galaxy as it was going.
Well, we do know now that galaxies collide more frequently than we thought. We have photographs of colliding galaxies.
Yeah,
so now we realize they probably have lunch more often than we thought. There's a black hole raging in the center of many galaxies, and they'll pull in neighboring galaxies and eat them alive. Andromeda, if you take a look at the core of Andromeda, there's two dots there, not one. There are two black holes, we think, inside the center of Andromeda. Probably because Andromeda, being so big, ate up a small galaxy, and the two cores are now at the center, in the stomach of Andromeda. And that's where we may wind up. When our galaxy collides with Andromeda, Andromeda may eat us up, and we may wind up in the stomach of the Andromeda galaxy.
Hopefully by then we've figured out some kind of drive system to get us across to
that's
another galaxy.
We have plenty of time to leave the solar system.
Oh, yeah. Well, I'm thinking we need to get out of the galaxy.
Well, in 5 billion years, we have to leave the solar system. The sun
the sun goes red
giant star in 5 billion years.
Yeah. They were talking about that, too, with the sun going red giant, that some of the outer planets and some of the moons around Jupiter and Saturn may find themselves developing life on them. But what is it? It's only going to last, 1.5 billion years before it dies out, right?
And we're going to have to leave the solar system by then.
Yeah.
I personally don't believe that we should be rushing to Mars right now. However, we do have to leave the Earth. It's the law of physics.
Yeah.
The law of physics is a death warrant for the Earth, and we're going to have to leave. Oh, by the way, the laws of physics are also a death warrant, we think, for all intelligent life in the universe. The universe seems to be headed for a big freeze. All the data now shows that the universe is accelerating out of control. It is careening out of control.
Yep.
Temperatures will drop in the future. The night sky will be totally dark, by the way. Billions of years from now, the night sky will be totally dark. And at that point, when all intelligent life is near the freezing point, near absolute zero, either we die with the universe or we leave the universe. And in my previous book, Parallel Worlds, I even gave you a blueprint of a machine. It's strictly hypothetical, that may use the laws of physics to leave our universe and go to a neighboring universe.
Yeah, we were talking about parallel universes, and that's something we may have to learn.
We may have to escape, not just from the Earth 5 billion years from now, but we may have to escape from the universe trillions of years from now. And hopefully by then we will have emerged into far beyond a Type 4 civilization and have the capability of going between universes.
Well, that's one of the things I also heard. Now they were talking 10, 50 billion years in the future about our species becoming almost an energy-based type species, losing its physical form. formed?
Well, yeah, there's many speculations. Isaac Asimov had a famous science fiction story where the universe was dying, and by then we had evolved, as you pointed out, into pure energy, able to teleport ourselves from galaxy to galaxy. But the universe was dying. So at the end of the short story, a computer was created to reverse the death of the universe. This gigantic computer assembled all the dead stars, all the dead neutron stars, all the black holes into one huge, gigantic clump, ignited it, caused a huge explosion, and then the computer said, "In the beginning, I created the heavens and the earth. And on the seventh day, I got tired and I rested."
That's interesting in itself. Oh, Lord. But like I said, I don't rule anything out these days. Half the stuff that I was taught was impossible seems to be possible. So, and I'm sure the rest.
Yeah,
of it
if you look
eventually
back at the kinds of things that we learned when we were in grade school, we learned that the continents cannot move.
Oh, yeah, that
There's
was
no such thing as continental drift. We learned that the dinosaurs probably died out because they ran out of food or something like that. And now we believe that there is continental drift. The Earth is radioactive, and the heat is pushing the continents apart.
Yes.
We believe that an asteroid or meteor or something hit the Yucatan of Mexico 65 million years ago.
Triggered the events that brought the dinosaurs.
Right. So a lot of things that were considered impossible are now considered standard science. And I mentioned this in my book, Physics of the Impossible. I have a chapter on all the predictions that went wrong.
Well, I can't wait till the book comes out March 12th, right?
Yeah, very soon it comes out. And by the way, if you subscribe to Discover Magazine, they're serializing a chapter of the book. If you subscribe to Natural History Magazine, the magazine of the Museum of Natural History, they're also excerpting a chapter of the book. Also, if you live in England, New Scientist Magazine is excerpting a chapter of the book.
Cool. I think I get one of those, actually. So, when do we get? I think the science one we get. We got a couple people in our house that are really into science and physics, and that and politics, unfortunately. But we stay away from. I hate politics. It's one of those things I try to stay far, far, far away from because I haven't found a good use for a politician yet. Maybe
a doorway.
Yeah, or maybe for some good weird physics experiments in the future. That's who we should send to colonize Mars. You see, because if something happens to them, it's not going to be any great loss. Oh man, that's something else. I know we're getting close to the end here, but colonization is an interesting thing for the simple fact that we need to colonize to ensure that the human species survives. Whether it's we blow ourselves up with nukes or an asteroid hits the planet or something else happens.
It's an insurance policy.
It basically is an insurance policy. And I agree right now, I don't think we have the technology. It's not going to be cost efficient. It's not going to be life efficient. It's not going to be cost efficient at the current level of technology. So I'm kind of with you on we should be sending a lot more probes there, a lot more robotic.
They're cheaper.
Yeah. Well, I mean, those little fold-up planes we can send over and scour the surface of Mars. There's all kind of robotic machines we can send over and scour the surface of Mars. And there are a lot of interesting features on Mars that, Arthur C. Clarke, his group, he has a group that actually analyzes the photos from Mars. And one of the things they had found a while back was these tubes. Now, these, of course, people want to make out these tubes to be all kind of things. I don't know what they are, but what's interesting, they've been found on something like 77 locations on the surface of Mars. They're all intact. None of them are damaged. They've got them inside of fissures that are opened up. They got them going through mountains. They got them coming up and down through the surface of the planet, which we know is being bombarded by meteorites. But yet every picture of every tube is intact. Whether it's a naturally occurring thing or something left over from a civilization is anybody's argument, but whatever the material is warrants a serious investigation. I mean, if it can withstand the radiation of Mars and the constant bombardment and fissures opening up and meteors hitting it and it stays intact, well, it's a significant material that we need to investigate. But yet I notice that NASA stays far, far away from that kind of stuff. And you got to kind of wonder why. I mean, it's obviously there. I mean, you can see it in hundreds of photos. There's no denying it's something real and it's on the surface of Mars. There's no denying that they're all intact. But yet they don't want to talk about it, which instantly makes me suspicious. I would think by seeing this, the first thing NASA would have said, well, we need to send a probe by one of these things and get a sample of it and see what it is. You know, because some people said giant tube worms, some people said lava tubes. Well, lava tubes would break. I've been around enough lava tubes that I know they're not that strong. You can step on one and break one. So I don't think it's that. So I'm curious myself what it is. And there's even one picture where you can see the thing, and there's something inside of it. It almost looks like it's got a elasticity to it or something, because it's kind of stretched around whatever this object is inside of it. But I can't tell you what it is. I can't tell you it's alien or some kind of weird animal that used to live there, or some kind of tube that was created through some other force on the planet. I mean, I don't know, but I do know they exist and they warrant a serious investigation. And personally, I think we should send several probes there. For me, it's the most interesting thing I've seen on the surface of Mars so far. The pyramid things and all just kind of crack me up because they look like dirt mounds to me. But this I found to be a substantial find, but like I said, nobody seems to want to talk about it. And I've written to NASA about it a few times, and they acknowledge the fact that they're there, but that's all they do. They don't even seem to be a little bit interested in it. So I didn't know if you had heard about them or not either. That's why I was telling you about them.
No, but for those people who saw the movie Total Recall, they're all true believers about ancient civilizations on Mars. But Total Recall was interesting at the end because Schwarzenegger terraforms the planet. And terraforming is something that scientists have seriously looked at. And, you know, to create a Garden of Eden on the red planet would be quite something. It would take several centuries, though, to do it. But several things have been proposed. One is to inject methane gas, a greenhouse gas, into Mars to induce the greenhouse effect, to heat up the planet. Another possibility might be to deflect comets. Comets are made out of water.
Yep.
You deflect a comet, nudge it into orbit, burns up as it orbits around Mars and creates steam clouds. And third is to nuke the ice caps.
Yep.
I personally don't think this is a good idea.
Yeah, the nuke one bothered me too.
Yeah, you can drop hydrogen bombs on the ice caps, melt the ice caps, so water runs freely on the surface of Mars. But it would take centuries to terraform Mars.
Yeah. Well, and it will. It is one of my favorite subjects. Mars has always been one of my favorite subjects in the terraforming of Mars. And, you know, I get people telling me, oh, we could do it in 10 years. I said, no. I said, we might be able to lower the pressure on Mars in 100 years enough to where we didn't have to wear bodysuits, but we'd still have to wear breathing apparatus. I'm thinking it's going to take 500 to 1,000 years to create a breathable atmosphere on Mars, simply because you're going to have to bring in plankton, you have to bring in other plants. I know we have special plants now for creating oxygen, but still, I mean, Mars is a big planet. If you're going to put an oxygen-rich environment over the whole planet, what is that? What is our oxygen level? 7%, I think. It's going to take time. It's not just something. I like the plans about sending the big machines there that just chew up the dirt and just burn it up and create a global warming effect, so they can raise the pressure on the planet, and then start, you know, because now NASA and the European Science Space Agency seems to think there's a lot more water on Mars than we originally thought. They seem
Well, it's in the permafrost,
yeah,
the ice cap.
Yeah, and they seem to think there's a lot more of it there. So this way, I mean, if you can create a greenhouse effect on the planet, it'll melt naturally on its own. The pressure will rise. You'll be able to move around on the planet without full bodysuits, but you'll still have to wear breathing apparatus. But there's still other issues. There's the simple 1/3 gravity environment. You're not going to be able to have children there. They're going to be deformed. You'll have to have some kind of 1G environment somewhere, whether in space or on the ground, so that the children can develop naturally. These are all going to be problems that they're going to have to deal with if they're going to stay there. You know,
Yeah,
if they're coming
like
back
Columbus.
and forth. Yeah, if they're coming back and forth to Earth, it's not a big a problem. But if they're going to stay there permanently, then these are problems they're going to have to deal with. Of course, I do like the idea you don't have to have stairs in your house anymore. You can jump from the first floor to the second floor.
Yeah, you'll be a Superman, but you may have to genetically modify yourself to adjust to the gravity.
Yeah, that's what I'm thinking. And in long term, we're going to have to genetically modify ourselves to live there if we're going to stay and breed and become part of the planet. I do think it's going to be a must, because unless they can figure out a way to speed the planet up to increase the gravity, which seems like a dangerous venture in itself.
That's thousands of years into the future.
Yeah, you know that. Yeah, maybe a couple of 100,000 years from now, if we can invent some kind of antimatter engines that we can attach to the planet and send it into a spin. But I don't know. It seems one of the things I think that could easily go awry and wipe out half the solar
Plus,
system.
you know, Mars is a small planet with a low escape velocity. So even if you do create an ocean on Mars, eventually it boils away again.
Yeah, it's just going to go. It's just going to go you're going to lose it. And they were talking about that. How can you lock it in? How can you keep it in there? And I'm just not, not in today's technologies anyway. But I do agree with you. I do believe within 100 years, a lot of these technologies will be commonplace technology. And then 100 years from now, things that we can't even dream of will be commonplace technology.
Yeah,
So,
in fact, that's the theme of the book, Physics of the Impossible, to show that what is impossible today may not be impossible in the coming decades to centuries.
but I know we're down about 2 minutes, so give them out your website. Tell them where the book's going to be found.
Right. I'm on a book tour in March, www.mkaku.org, mkaku.org. Is the website. We average about 1 million page hits per month on the website. I'll be on a book tour in March, so maybe I'll be in your neighborhood. Maybe I'll be signing your copy of Physics of the Impossible.
Well, if you get down in the deep south, I'll be looking for you because I'm in New Orleans, but still getting over Hurricane Katrina. But ladies and gentlemen, you will be able to find Dr. Kaku's book on all 3 of our websites. We will put links there, linking back to his site or to where the books are at, or both. So you should be able to easily find them. It shouldn't be a big deal. This will interview again at its regular time on March 12th, the day after the book release. This show will air on the regular network from 7 to 9 o'clock, so y'all will be able to hear it again then. Also, Dr. Lavalette's interview will air next Wednesday for anybody listening to us live right now. Dr. Kaku, I got to tell you, thanks for being on today. You were great. I immensely enjoyed it. I know we barely even touched on half of what I wanted to talk to you about. But I got to say, it was a fantastic interview, and like I said, it will air again on the 12th. So it'll be in the archive system as of today, but I won't release it until after it airs officially. So it'll be there, but like I said, I won't release it until the 13th, and the archive will be up and available for anybody who wants to listen to it. Okay. But again, I want to tell you thanks for being again one more time. Tell them where the book's at.
Okay, go to mkaku.org, mkaku.org. The book tour schedule is there, and all the bookstores will be carrying Physics of the Impossible in March.
And most of your other books you're still able to get them, right?
Oh, that's right. Hyperspace, Parallel Worlds, Visions, they're all selling very well. However, the other books I should mention are for PhD level students, so you may not want to pick up my PhD level book.
Yeah, guys, y'all understand that. Start with the easy stuff, okay? Well, none of it's easy, but start with the easy stuff and work your way backwards. But again, I want to tell you thanks for being on today. Ladies and gentlemen, it's been a good show. I hope everybody enjoyed it today. We'll be back at our regular time next Wednesday, 7 to 9 Central Time. Until then, enjoy your lives, people. Ask why. Ask. Just ask any questions. I don't even care anymore at this time. Stop being sheeples and ask a question. Anyway, on that day, thanks again for tuning in today, and I'll see all of y'all next week.
Good evening and welcome to Chasing Prophecies Halloween special on FM 105.3 New Orleans, where we discuss anything and everything beyond the scope of normal. I'm Sister Barbara Ann, along with my guest, Sean
Ann.
Kelly, Jason Ibijo, Trish Mo, but she's not here for some reason. I don't know.
She said she's coming.
She said she's coming. Yeah.
Wow, we have an interesting show tonight, guys.
Ooh.
Yeah.
I don't know. We're Dr.
Yes.
J's an invisible man, I think.
Oh.
Well, I think I might have fixed my camera. Hold on a second. Let me see. I made a costume specifically for the show.
Oh, well, would anybody like some chocolate? And we have some popcorn balls, and we have some musketeers.
Hey guys,
Are you
happy Torture
supposed to
Tuesday.
be
I'm
me?
Jenny Nicasio.
Yeah.
Oh my God, that is so freaking funny.
It is.
Oh, I love
It
you,
is.
Jason. You cracking
Isn't
me
it
up,
great?
buddy.
That's good.
I have some nice lashes there for you, Jenny. Some lip
Oh,
gloss.
you look so beautiful. Oh my God. That is just so funny. Oh
little
my
earrings.
God. Oh, I have to tell my fan club to put you on just to see you. Oh my goodness gracious. That is hysterical.
I dedicate this costume to you, Jenny.
That's so
That is
good.
hysterical. I
It's
can
epic.
see that, Jason. You're cracking me up.
It's epic.
Oh my God. Wait, I gotta put some. This
That
sounds
is
funny.
That's so epic. It is.
That is the greatest.
Yes. Where's your
Oh
mom?
my.
Where's your mom?
Oh my
Where's
God.
your
This
mom?
is
Where's your
hysterical.
mom?
I have to take a picture
There's my
of
mom.
it. Oh,
There's your mom.
Jesus. Oh, my Lord. Oh, Hail Mary.
Hail
Oh, my God. This is
Say
so
a prayer for me,
wonderful.
Sister Barbara Ann.
Sister Barbara. Yes, we